Hi everyone, welcome back to this YouTube channel of AC Intelligence. We're very pleased to show you how you can update the default certificate into your OpenShift cluster. We show you how you can generate a certificate and also how you can apply it in your OpenShift cluster. It will be a very interesting subject that we have to master by the end of this video. So let's get started. Okay, so before proceed, let me show you how it looks like the default certificate into your OpenShift cluster. As you can see, your connection to this site is not secure. Let's see the default certificate information. As you can see, issued by the Ingress operator. And here is the different detail of this default certificate. So this is why we intend to update. And by the end of this video, we will not be able to see anymore this current default certificate. So let's move on the console. So here we are on this particular client, which will be able to interact with our cluster. But first of all, let's generate the root certificate, I can say the custom certificate right now, and after that we will also sign this certificate because it will be a self-signed certificate that we intend to apply to our cluster. So let's proceed by generating our root certificate. So this is what we intend to do. So the first step to generate the root certificate is to generate the private key that will permit us to create the root certificate. To create a private key of our root certificate is pretty simple. Here is the command. Oh, sorry. Yeah. Here is the command to generate the private key of our root certificate. Open SSL gen RSA -out training -ca key and the length of our private key. This is the private key that I intended to generate. This is done. Yeah, let me just create a folder where I intend to okay, so I regenerated all the different files into this particular folder. Okay, so let's now regenerate again the private key. So here is the private key of our root certificate. Now, based on this private key, I will generate the root certificate. To achieve this one, it is pretty simple. As you can see, it's a little bit big. Let me just change the settings of appearance. Yeah, okay. So as you can see, here is the command to generate the root certificate based on the private key that has been generated before. And here is the different information of our organization. And another thing which is very important, the domain on which this root certificate is based. Okay, our domain will be example.com. This is the domain on which this root certificate will be related. So let's do that. It's done. Now we have our root certificate that has been generated. It's very important to have or keep this root certificate secure. Okay. So based on this root certificate, we will now generate another certificate, which will be a wildcard certificate that we have to that we will really be able to sign this certificate. So let's progress. Now let's generate first of all, before proceed, we generate the CSR, okay, which is the certificate sign request that we intend to generate. In order to generate this CSR, we first of all generate a private key that permits us to generate this CSR. So here is the new private key, and based on this private key, now let's create the salt at name. this salt alt name defines the different domain that will be linked to our wildcard certificate. Okay, let's just correct this one. Yeah, so all domain which will be under this domain will be signed by our wildcard. Okay, so let's create the salt alt name. The subject alt name, just to sum up this pronunciation. Okay, very important to have this one if we intend to generate a wildcard. And after that, we will generate our CSR. This CSR is mandatory if you intend to send it to another authority, okay, which will a well-known authorities which will be able to send your wildcard. But in our case, we will send our own certificate. So it will be an self certificate that we will intend to use into our cluster. So let's generate a CSR. Okay, this one will be our CSR, as you can see here. This one will be our CSR that we intend to generate. Okay. The CSR has been generated. Okay, so now let's sign this CSR right now. So now we will sign this CSR based on our subject alt name. Okay, so as this file has been created before, and the content of this file is this one that we are already discussed before. Okay, so let's generate our let's sign our certificate right now. Okay, so the new certificate has been now generated. This is this one. Great. Now we have our certificate that has been generated. The wildcard certificate that has been generated. Great, and congratulations. Now we have to proceed to apply this new wildcard certificate into our cluster. But before do that, we have to do another action which is very important. It is to combine this root certificate with our wildcard certificate that has been generated. It is very important to do that, and before do any action, we have to combine those certificates. Okay, so it is this full chain certificate that we have to use into our cluster by combining the root certificate. Okay, by combining the root certificate and the wildcard. Now we have it will be this full chain certificate that we have to use and apply it into our cluster. Okay, this is this one that we need to use right now. Now let's move on our OpenShift cluster. Everything has been done properly. Now we can go into our OpenShift cluster with a user, with a cluster admin user, and to proceed to the update. So let me log in to my cluster. So we say login, OC. User, yeah, connected. Great. Now I'm connected to this to my cluster. Okay, just confirm. We'll say okay, and the URL. Great, so I'm on the right cluster. So now I can, the first thing to do is to update. We have to update or to create a new custom or how can I call it? We create a new config map called custom CA. Okay, we create a new config map right now. So we will create a new config map on called custom-ca5. It's our name. You can call it whatever you want. Okay, so we will create a new config map, and it's based on this config map that we intend to do the next we intend to do the next action, which consists on update of the cluster-wide proxy configuration with a new created config map. Okay, it's mandatory to do this action because we intend to add a new certificate to the cluster. So to do this action, we have to apply or update the cluster-wide configuration. So let's update the cluster-wide configuration because you just intend to update to add a new certificate to the cluster. This action is mandatory when you intend to add a new certificate to your cluster. Okay, so once this one has been done, we can move to the next step, which will be to update the cluster with your wildcard certificate that has been created before. Okay, but before do that, we have to create a secret. Mandatory. We have to create a secret first. Let's create a secret. Okay, so we create a new secret for our Ingress controller. Just do a last check. Okay, so also create a secret TLS. Okay, TLS secret, and the name of a secret. Okay, and this name of secret will have two parameters: the full chain certificate and the private key that has been used to generate our wildcard. Okay, done. Perfect. Now, once done that, we can now update our Ingress controller properly. So let me do that rapidly. So the command is pretty simple. Okay, is this one also picture Ingress controller operator, and now we have to specify the name of your Ingress controller the Ingress controller. Okay, secret that has been created before. I'm doing just a last check to be sure that nothing has been done badly. Yeah, great. So we can proceed. If you would like to monitor all events to be sure that nothing bad is happening, to be sure that everything is okay into your cluster, we can hit the command. Okay. Also get event to see if everything is ongoing properly. As you can see, the node is not ready just because of the updating is ongoing. Just waiting about 1 minute to be sure that everything is coming back on the ready state. Normally it is okay here. Wait a moment. Great. Okay. Now the creation of a new pod for our router has been done successfully. So let's see that if there is no more error. Okay, great. Just wait a moment to be sure that there is no more error. Okay, great. So no more error. That's a very good news. So next step is to test. We just have to connect again to our cluster with another user. Okay, just to be sure that everything's okay. But before proceed, at these steps, your cluster, the certificate has been updated successfully into your cluster. But this one has been updated with a private certificate. Okay, it has been updated with a self certificate. Okay, so because of that, all clients who would like to interact with your cluster should have your root certificate at the side. Okay, I repeat again, at this step, your cluster has been updated with a self certificate. So that means that all clients who would like to interact with your cluster should import your root certificate. Okay. Let me show an example to illustrate my word. Okay. So if I right now, if I intend to log into the cluster with this user, I will get this error. Okay, TLS failed to verify here. Okay, right now I have this error just because of this node, this external node who will intend to communicate with my cluster do not have information about the root certificate. So I have to import the root certificate to this particular node. Okay, so to do that, it is very easy. Just import the root certificate to the client. Okay, and let's see, done. And now I will update the database of this client with my now I can be it will be able to communicate or connect to the cluster without raising this alarm. Okay. Next step, so let's say it will be the same case with this client, which is a Chrome client. Okay, who will intend to communicate with our cluster. It'll raise also the same alarm. Let me do that. Okay. Error set authority invalid. Just this one. Okay. So I have to import also. I have to import just to let this client trust my cluster. Okay. We have to import my root certificate to this client. Okay. We have to do this one. So let me show you. Let me show you how we can resolve this issue. Just coming here in the settings, and from there I will go to private security and security here. I will import the root certificate in this particular browser. Okay, so let's do that. So here is the root certificate. If you remember, it's this one. Oops. You just import this root certificate. We create a new file. Okay, once done, we go back here and import this root certificate. Oh, where am I put you? Download. Yeah, no, okay. The extension is not good. Okay. CRT. Yeah. Okay. Okay. Great. Okay, close. So now let me try to, I'll just close this one and okay, just a moment. I mean, maybe just a moment. Let me close it and okay, great. I have to close it here simply. Okay, great. So now our connection is secure. Everything's okay. Everything looks okay. Nothing bad. And our certificate is valid. Great. And it has been issued by the organization EC Intelligence. Okay. Very interesting. And congratulations. And yeah, we can proceed further by by deploy application on our cluster and enjoy our cluster. So thank you very much for those who successfully reached this part of our video. Again, if you have any comment or any request, please consider to drop some comment in below this video, and we will be very proud to reply to you. Thank you very much and take care. Bye from now. So this is the wrap up about how to can updating the default certificator into your OpenShift cluster. By following the previous steps, you will be able to update properly the default certificator into your OpenShift cluster. If you found this video very helpful for you, please consider to give a thumbs up to this video, and also please consider to subscribe to our channel. Thank you very much and see you in the next video. Bye from now and take care.